Hi, welcome to an Arduino tutorial and product review by Robojax. In this video, I'm going to introduce the library that I have written for BTS7960 pulse width modulation motor controller, and we are going to test it to see how much maximum current it can handle. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. This module, the BTS7960, is sold on eBay, AliExpress and Amazon for different prices. And here on Amazon.com, when I type BTS7960, we will be getting this different prices: $13.59, $22, $10, depending on location. And here on eBay.com, it shows $5 from China, which might take about 30 to 60 days. You receive it at different prices, $8 with the shipping. And here on AliExpress for 15 plus some little shipping, or different prices as you can see here. I will provide you the link. I have no affiliation with any of these. Heatsink is not touching directly to chip, so that makes it a little less conductive. Also, the path of the current from the terminal to the chip is from PCB, and that will be problematic, which I'm going to test later. And then the terminal, if you want to go for 20 ampere or 30 ampere, this is very small in terms of size of the wire that you can connect. Here, let me explain the module. These are the two chip BTS. With this, you can control motor in both direction. Here are the terminals for the power. And they've been labeled as B minus, B plus, so that's for the battery or power source, and M plus, M minus, this is for the motor. This is a big capacitor, that's a filter. When the inductive load changes, it just eliminates the spikes in the power supply. We have 4 pins here. They have been labeled in this 4 boxes, and these 4 pins in here have been labeled in here. These two, this is referring to pins that are connected to this as right, R, and this has been labeled as L. These 3 pins are for this chip, and these 3 pins are for this chip. This have been labeled as R, which is a right or right direction pulse width modulation pin. This is EN, enable pin for that, and that's IS. I is a current, S is a sense. This is a current sense output pin for this. And then this is VCC, 5 volts for the chip to operate, and this is ground for this. So this 5 volt is just for this section, and this module is being powered from the main power. Same way, enable, current sense. So these 3 are for this. We have a very small heatsink with comparing to the claiming of 43 ampere for this module. This is not enough, but we are going to test it and see. Width of the module is 50.9 millimeters by 49.7 millimeters. The depth or height, including the heatsink, is 41.3 millimeters. If you're interested in this section, it is 20.4 millimeters. And if you're interested in the weight, it is 64 grams. This is the datasheet for BTS7960 motor controller. This chip is from Neon Technologies. They have labeled it as 43 ampere, 7 ohm plus 9 ohm. This is the turn on resistance. This is the PTO263-7 package. This is the PTO227 package. And the 7 refers to number of pins here, and 263 and 220 are the shape. We are using this one in the module. It acts as a resistance of 16 milliohm and pulse width modulation capability of up to 25 kilohertz. Current limiting level is 43 ampere typical. And it has current sense, which I'm not going to do it. It has over temperature shutdown, over voltage lockout, under voltage shutdown. Chip, all the pins. We have 3 here and 4 here that have been mentioned. This is a VCC. We have 2 MOSFET switch. One is the negative, the other one is the positive. One is for high side and then lower. This is a supply current, 2 milliampere. It has the following short circuit protections. Output short circuit to the ground, it will be protected. Output short circuit to the voltage, short circuit of the load. We have two of this chip that is connected. This is the supply voltage from here, and it enters, and this is the ground. The output from this chip is this pin and this pin connected to the motor. When this upper portion is on, the positive comes and enters here, and we must turn this on. So this way the current goes to the ground and motor rotates, let's say in clockwise direction. And when you want counterclockwise, you will turn this on and this on. What happens is the positive will come and enter from this side. Before it was coming from this side, now it will enter from this side, and it goes from here to the ground, and the motor will rotate in the other direction. I will provide you the link for this datasheet if you need to have a look at it. Whether if you're studying mechatronic, electrical engineering, hobbyist, researcher, or high school student, I have an Arduino course that will teach you from ground up Arduino. My Arduino course at Udemy is arranged such that all the material are structured from absolute beginner to advanced, including all the library, codes, schematic diagram, and explanation step by step for all the projects are available to you. In no time, the knowledge that you gain from my course in Arduino, you will be able to implement it and build cool robotic or mechatronic projects that is beneficent for you and people around you. The link for my course on Udemy is below the video in the description. You can visit it now. Here I have 8 wires, female to male, that have been inserted on this side, and the 4 wires will be inserted on the first row here, and the second 4 will be inserted on the second one. So let me insert these 4 first. The 4 has been inserted, again in the same order. The other 4 will have been inserted there. Now, because the first 4 that we have, the last one is VCC, and the second line, the last one is ground, I have to pay attention. So I will take only these 3 from here and insert it from pin 3 and up, 3, 4, and 5. And then this is for VCC. The 4th wire goes to 5 volt VCC. And then I have these 3 wires. They will accordingly go from pin 6, 7, and 8. I've inserted them here, 6, 7, and 8. And the last pin, which is connected to the ground here, will be connected to ground and here. And the wiring for this portion is done. And here on this side, these 2 pins will be connected to a motor. I'm connecting this motor. It's up to you what type of DC motor that you connect. And these 2 wires are connected to my battery, to my power source. I've spent almost 1.5 days working on the library and testing this module, studying about the material, preparing, writing the library code, and testing it and recording and uploading, so you can easily use this code and learn about this. The least that you can do for me is to click on the subscribe button and leave the notification on. It's really appreciated. Thank you. Let me explain the code. First, you will download the zip library that I have provided the link. Follow that and download the zip file. Once you download and save it in your computer, click on Sketch, include library, add .zip library, and then point it to where you have saved it, either desktop, my document, whatever. This is an example. Suppose this is the zip file that I have downloaded. Click and click Open. Once you're done, close this Arduino. Make sure there is no instance. For example, there is 2 instances of Arduino. Close all of them and reopen it. Once you opened, click on File, Examples, and then scroll down, and you will see Robojax BTS7960, and open this BTS7960 motor controller basic. We are defining the right pulse width modulation or enable. This is inhibit, but I put EN because it was labeled the same way on the board. Pin number 4, and this is RIS, that is the current sensing, pin number 5. So I put them in order the same way that they appear on the board, 3, 4, 5. But remember, this 3 must be one of those pins that has capability of pulse width modulation. And the same way R pulse width modulation, number 6 is the same as 3. This is pulse width modulation enabled pin. And then LEN number 7, LIS. So same pin, just I put R here in front of them, and you will see 7 and 6, 7 and 8. These two are used, 1 for clockwise and 0 for counterclockwise. Do not change it. And then we debug. We set debug 1. If you set this 0, the serial monitor will not display anything. Right now the motor is disconnected, but these are the value that continuously it shows which pin is high, which pin is low, and how many seconds. So, and this line that include Robojax BTS7960.h. This is a library just downloaded and installed, and from here using the instance of this class, and we call it motor. This is an object, and we are passing all those value REN or pulse width modulation or IS. These 3 is for the second one, and then debug is at the end. We are passing this variable to the class or library to work with. Inside the setup, we initialize the serial monitor. If you are enabling this one as 1, you must define here, and I did not include this in the library because this the baud rate of a serial monitor is something that differs from computer to computer, or people they set the right corner on the lower right corner, that's 9600 baud. And then we start the motor initializer by motor.begin. This is the motor, and we use motor.begin. This is a function or a method that initializes the motor, assigns the pin, and make it ready. Inside the loop, this is how we control the motor. Motor.rotate. So if you want a motor to rotate, here you put the percent. 100% means full, or 0 stop, and in between. And then this is clockwise or counterclockwise. So this line will make the motor to rotate clockwise at 100% speed for 5 seconds. Then we stop the motor using motor.stop. This will stop the motor, and then for 3 seconds, and then rotate to counterclockwise. This was clockwise, and this is counterclockwise, and then motor stop for 3 seconds. This is just another test. It initializes the for loop I equals 0, and it goes up to I equal 100. This is incrementing it, and in this line we type motor dot rotate, and this is the speed. I is 0, and then clockwise, and then 1, 2, 3, 4, 5. It goes up to 100, and every time in between we have 50 millisecond delay. So in total it will be 5000 milliseconds when it reaches to 100. So 5 seconds. In 5 seconds the motor will increase the speed from 0 to 100%, and then this function will start from 100% until it reaches 0. Again the same way, except the number decreases, and after that we stop the motor for 3 seconds, and the loop continuously doing the same thing. Now let me demonstrate it. Everything is connected. I'm holding it with hand and connecting the power. So this is just a beginning with 100%. Now 6 and 3 will be swapped. 100%. And then now we go from 0 to 100%. You see, when you disconnect it, it runs for a while, but the stop function that I have written, it will stop the motor very quickly. Now this code will run the motor in counterclockwise for 20% speed for 5 seconds, then stop it for 3 seconds, and then we will go back to the previous code, which is 100%. This is 20% for 5 seconds, stop, and then it goes now 100%. Let me go 10%. Now let's see if 10%. So this motor can run with 10%. Let me go. Now this is 5%, let's see. Stop, and then it goes 100%. This is the electronic load DL3031, and these are the two terminals that from the circuit will be connected in here, and we will see the voltage here and the current. Now I've set up this, I've connected it, the 2-pin instead of motor, I've connected this to a load, electronic load, which I have just shown you. These two have been connected. Here is the output from this. This is the voltage now. Let me make it 12 volts. So the voltage is 12 volts. Now there is no current. Constantly it goes now at 100%. So I've set this, programmed this so it can always send 100% and in one direction, because my load needs a specific direction. And then now, because it's 100%, let's test it with 20 ampere and see if it can handle it. Now 20 ampere is being drawn. We have a little voltage drop, but already heated up. Now 30 ampere is being drawn from this. Too hot. Let's see. Extremely hot. Let me compensate for the voltage. Already heated up. I can see the smoke. I don't know if you can see it. The smoke is coming out. The problem with this heatsink is that the piece is directly not attached on the heatsink. So this is on PCB, and they put multiple holes of hole through metal, so the heat is transferred. This is not an efficient way. 40, shut down. You see it did not work. Turn off. 30 ampere. Let's make it 20. So it's extremely hot now. Exactly, the chip on the right is the hottest one. Here I'm running this code, which goes from 0% up to 100% in 5 seconds, and then from 100% to 0 in 5 seconds, and that is what is going on continuously. And here is the waveform, and I set it for 2 ohm resistance, and this blue is the resistance, as you can see, and green is the current. This green is the pulse width modulation. The duty cycle increases and then it goes to the maximum and it comes back, and there is one jump and it's going on. So right now this is how this is behaving. So conclusion is that this cannot handle with this heatsink 20 ampere continuously at 12 volts. 15. I reduce the current to 15 ampere. Thank you for watching. This was how to control this BTS7960 motor controller. This module is amazing with the amount of power that it has, and quick stop and start, and a lot of protection over heat protection, over current protection, and definitely recommend this. I have no affiliation with them, and if you like this video and learn something, please thumb up. If you have comment or question, post it in the comment section below. I always try to answer and reply. And if you have not subscribed, please do so. You can get updates of my upcoming videos. To 100%. You see, when you disconnect it, it runs for a while, but the stop